Hi, ladies and gentlemen, this is Mr. Green, and this is another in my series of lessons for geometry. Here's the deal. I have to be in Dallas today and for a teacher meeting, and because of that, I cannot be in Class Connect. So I'm making this recording for you so that you will have a good review before you take the unit exam on Friday. Okay? So, where should you be? You should be finishing everything in Unit 1, getting ready to take this unit exam on Friday. So be ready for that, okay? If you haven't already, make certain you go through all the quizzes in Unit 1, make corrections to them, submit those corrections. The corrections give you a few extra points. You need to make certain you get them done. Due dates, 28 days after they're due, they are locked up. So you want to make certain you get them done before they get locked up and get a permanent 0 in your grade book. Okay, so here we go. Unit 1 review. Distance. There's a formula for calculating the length of a space diagonal. Okay? Space diagonal. That's the one that goes through space. Okay? And so, uh, of a right rectangular prism for the basis of the prism's length L, width W, and height H. So what you're looking at here is you've got a rectangular prism, right? I'm doing this freehand, so you have to excuse it. A right rectangular prism here looks like that, and a space diagonal, that's the one that would go from one corner, like this upper corner up here, to the bottom corner on the opposite vertex over there. It's going through space. It's not on any one of the sides. It's not on a side at all. It's going through the space that's in the middle of it. Okay? That space diagonal has a formula. Basically, what you can say is that it is a distance. That distance is found by the square root of the length squared plus the width squared plus the height squared. That would be the length of that space diagonal. Okay? Not a tricky thing here. This is the same as the distance formula that you had in 2 dimensions, but now we just have added the 3rd dimension, the height. Okay? So it's not really a problem at all. So this one is asking me to find the surface area of this prism. Well, there's a couple of formulas that we have used for that. One of them is we've used a net and laid it out to look at each one of the different sides. And if we do that, we see this base down here on the bottom has a 4 by 3 or 12 meters squared. And so with the top up here, this side over here is a 2 by 3, that's a 6 meters squared. And so with this end over here, okay, and this would be a 4 by 2 that has an 8 meters squared. And so with the back here. And so if we add each of those up, we have 12, well, 2 times 12 plus 2 times 6 plus 2 times 8. And so we've got 24 plus 12 plus 16. That's 36 plus 16, that's 46, that's 52. 52 meters squared. That's how you find the surface area of a prism. Okay? Now there's another formula that I'll give you second chapter that helps a little bit, makes it a little bit easier, but we'll deal with that formula right at the moment. Now, what is that again? That's the amount of paint it would take to paint that prism. Paint all 6 sides of that prism so that you could have it completely painted. That's the amount of wrapping paper it takes to wrap that box if you were using it as a present. Okay? Volume. If you're finding the volume of a prism and it says it's 30 centimeters cubed and the height of 15. Okay? It's telling you that the base is 30 centimeters squared. Squared. So that's what the area of the base is. What you do is you take the area of the base and you multiply it times the height. Okay, I used the wrong letter there. to find the volume, you take the area of the base times the height. And so it's just a matter of plugging the values in. 30 times 15. That'd be 300 and 450, or 150, 450 centimeters cubed. That would be the volume. Okay? And I want to check that because my calculating that in my head, I always like to make certain I did it correctly, especially in a class connect like this. So 30 times 15, and we get 450. Woo. Okay? So let's go on and look at another question. 3D space. When we're looking at three-dimensional space, you've got three coordinates: an x-coordinate, a y-coordinate, and a z-coordinate. If you look at point Q right here, it's way out back here in space. The x-coordinate, it came forward 2 units, so my x-coordinate is going to be at 2. It went down the y, 1, 2, 3, 4, 5, and this is the negative direction, so that'd be minus 5. And it went up the z, 1, 2, 3. We have located point Q. For point A out here, it's going on the x, it went 1, 2, 3, 4, 5, and it's in the negative direction, so it's at minus 5. And look, I'm looking at point A, okay? It goes on the y direction, 2, and in the z it goes down 1, 2, 3, 4. Can you see how I'm just counting based upon these boxes that are drawn here? I'm just counting the number of units on each axis. That's all you got to do to count those values out. This is where A is located. This is where Q is located. Okay, distance between 2 points in three-dimensional space. Just like that space diagonal, all you got to do is find the difference in the x values, 8 minus 6. The difference in the y values, minus 3 minus a negative 4. And the difference in the z values, 4 minus 1. Take each one of those values, you're going to square it and add them together. And then you're going to take the square root of the whole thing. Ta-da! Difference in the x values, difference in the y values, difference in the z values. So 8 minus 6 is 2 squared plus negative 3 minus a negative 4, that's going to be plus 4, that's going to be a 1 squared plus 4 minus 1 is a negative 3 squared. Okay, so that's going to be 4 plus 1 plus 9, that's going to be 14, and you got the square root of 14. That would be my distance between those 2 points, square root of 14. Now, I've been asked a couple different times, would I key that into my calculator and get the approximate value? Only if they ask me to approximate it, which is what they're doing right here, to the nearest tenth of a unit. So that's where we've got to key it into the calculator and find out the value of it. So I'm going to take the square root of 14, and we get 3.7. 3.74, so it is 3.7 units. That'd be to the nearest tenth of a unit. Okay? Equations for a plane. What you're doing here is you're locating the intercepts. Okay? These points right here where it intersects the axes. That's where this plane is intersecting the axes. And they actually gave us the points right here. So what I'm going to do is I'm going to take the general equation, ax plus by plus cz equals d. I'm going to stick each one of these in. If I stick a 2, 0, 0 in there for x, y, and z, I'm going to get 2a equals d, or I'm sorry, a is equal to d over 2. I'm going to stick a 0, 4, 0 in for the x, y, and z, and I'll get a 4b is equal to d, or b is equal to d over 4. I'm going to stick 0, 0, 5 in there, and I'm going to get a 5c is equal to d. And if I divide by 5, I'll get c is equal to d over 5. Now I've got values for a, b, and c that I can stick back into this equation right here. And what do I get? I get d over 2x plus d over 4y plus d over 5z equals d. Now I've got d's in every one of them. I can divide that out. I'm looking for a common denominator, and I see 20 as my common denominator here. So if I multiply the first one by 20 and divide by d, so multiplying by 20 is going to give me 10x plus 5y plus 4z equals 20. And all I did was multiply this whole thing by the common denominator, 20, divided by d. If I multiply 20d times this one, the d's cancel out. 20 divided by 2 is 10. If I multiply the next one by this, the d's cancel out, and 20 divided by 4 is 5. Multiply 20 times this one, the d's cancel out, and 20 divided by 5 is 4. Multiply this times the constant out here, d divided by d cancels out, and I'm left with 20. This would be my equation for this plane that is right over here. Okay. Now, planes intersect the axes no more than 3 times. They can do it 3 times, but they cannot do it more than 3 times. They can have 2 intercepts, or they could have 1 intercept, but they can never have any fewer than that. They have to have at least 1 and no more than 3. At least 1, no more than 3. That's an important point. If you think about the axes, like this, okay? If a plane only hits the axis 1 time, that must mean it's like the ceiling of your house. It is flat, it's a plane, it only hits the z-axis 1 spot. If you're talking about this plane out here, it's like your garage door. It's only going this way. It's only hitting on the x-axis. It's not hitting on the y-axis at all. Okay? And this would be, z would be some other wall in your house. It's only hitting on the y-axis. It's not hitting on the x or the z-axis at all. And so you could have a house here that has different planes, right? And those planes are just never intersecting the other planes. Just like that. Okay? So that's where we just did 1 intercept. Now if it intersects 2 planes, it must mean that it leans up against 2 walls, but not against the 3rd wall. Sorry, brain went off here. So edges of a prism. If it tells you to find the edges on the base or the edges on the sides of a prism, what it's going to do is it's going to draw a prism for you, like this. It's going to label each one of the sides. A, B, C, E, F, G, H. Okay, I've got all my points labeled now. or vertexes. It says find the edges of the base. Well, any two points down there, AB, BC, CD, AD, those would all be considered valid edges of the base. It says multiply by 2 to find the edges on both bases. Oh, okay. What they're actually asking you here is how many edges are there on a base? Well, there's 4 of them. 1, 2, 3, and 4. If I multiply that by 2, because there's a top and a bottom, there are 8 total edges. So the number of vertexes for edges containing bases, well, there are 8 vertexes on here too. How many faces are there? There are 6 faces. Okay? This is a matter of being able to identify how many edges, how many faces, and how many bases do we have. Okay? 8's not right there. There's 12 edges because there's 4 on the bottom, 4 on the top, and then 4 connecting going up. So there's 12 edges on a prism. Okay? Okay. Moving forward. This is a vanishing point. It's the point in which this isometric drawing vanishes. It disappears off into here. Now there's a different type of one that actually has 2 vanishing points on it, and that's where both, not only would this side appear to disappear off in space, but this side would also have disappeared off into space. As you can see in this one, this side and this side are the same length. It's this one that's a little bit smaller than this one. Okay? But there's a lot of different ways that you can represent three-dimensional objects in space. Okay? The one you see me doing most often is called a perspective drawing. This is a 1-point vanishing point. There's also a 2-point vanishing point. You need to be able to recognize those different types of representations. Midpoint. Midpoint is just like in a 2D space. You add the coordinates together. So in this particular case, I would take -6 plus 4 and divide by 2. That'd be my x-coordinate. My y-coordinate is going to be 3 plus 7 divided by 2. My z-coordinate is going to be 4 plus -6 divided by 2. And we can find that midpoint real easily. -6 plus 4 is -2 divided by 2 is a -1. 3 plus 7 is 10 divided by 2 would be a 5. 4 plus -6 and -2 divided by 2 is a -1. So I have located the midpoint to be at -1, 5, -1. Moving forward. Dihedral angles. Dihedral angle is an angle between a plane and another plane. So if I'm looking at this prism that's drawn right here, and they tell you that this angle right here is 50 degrees. How do I know they're telling me it's that one? See how it says EAJ? Putting my point on E, going down to A, going up to J. That's the angle they gave me. They told me that's 50 degrees. Now they're wanting to know what is the dihedral angle formed between the planes ADIJ. That would be this plane in here, the one that's sloped up, and the base, this base down here. Now we don't have that angle, but we know that that angle is this one right here, and it's a complement of that 50 degrees. So it's 40 degrees. What have I done? I've took 90 minus 50 and got 40. It's the complement of the angle that they gave me in this particular problem. You just have to look at what angle they give you and what you're looking for. Okay? So, for your part 2, you will be having to find the equation for a plane given 3 points. You will have a couple of other problems in there, but this is a general review of everything that we have covered in the course. You should be able to do the problems that you're asked to do. If you have any questions, get in touch with me. Send me an instant message. Send me a text message. Send me a K-mail. Get in touch with me. I look forward to hearing from you, and I'll see you next week. Oh, I'll see you next week. Secret word for today is football. So if you're watching this, I do want you to send me a K-mail telling me the secret word so I can give you credit for having watched the review. Okay? Don't forget to tell me that you're in geometry and tell me what section of the geometry course you're in so that I can give you the full credit. Okay? I look forward to seeing you next time.